Hey guys, I'm back. Sorry that I'm new with technology, it kind of cut me out there. So what we're going to look at now is how the parent function compares to the new function, but this time we're going to add a constant on the inside of the absolute value bars. And actually, behind the parentheses here, we're going to put this. We're going to put moves graph left or right. But we're also going to put comma, but not what you'd expect. Because it's actually going to move it in a way that is kind of what we call counterintuitive. That means kind of going against what you instinctually thought it would do. So we're going to go underneath and we're going to put an A. And again, we're going to put our coordinate plane here, X and Y axes. And we're still going to be plotting both the parent function and our new function. And our new function is going to look like this. Y equals absolute value of x plus 2, and that's also going to be in the absolute value bars. So we're going to go ahead and plot this guy first. We already know the coordinates for these. It's going to be -2, +2, -1, +1, 0, 0, 1, 1, and 2, 2. And connect those with your V. Whoa. That's an arrow. There we go. And use your highlighter here. Alright. Now I'm going to, because I know what's going to happen with this particular graph, I'm actually going to extend a couple points over on the negative side of my x-axis. Just like that. You're going to see what's going to happen as we start to plot the coordinates of this particular one. So I'm going to go ahead and once again plot the points of this particular graph. So I'm going to start with the ones that I normally do, -2, -1, 0, 1, and 2. But you're going to see as I start to go through these, let me move that down. As I start to go through these, what's going to happen to my vertex as I move through these different points. So if I plug in -2, -2 plus 2 gives me 0. So absolute value of 0 is going to be 0. If I plug in -1, -1 plus 2 would be +1. Absolute value of +1 is 1. Plug in 0, that would be 2. 1, that would be 3. And 2, that would be 4. So you can kind of see it's almost like shifted towards the positive side. So I'm going to go ahead and plot these, but then I'm also going to show you a couple of different points that we're going to plot kind of on the other side of the V. So let's go ahead and plot these. We have -2, 0, -1, 1, kind of on the same point as that one there. 0, 2, 1, and I think I have to plot some more points. 3, and 2, one more here, 4. So we kind of have the one side of this V. I'm going to plot some other points that give me the other side of this V. So I'm going to start at, and I'm just going to do it underneath because I don't have any room here. There we go. I'm going to do -3 and see what happens. If I plug in -3, -3 plus 2 would give me negative 1, but the absolute value of negative 1 is positive 1. So that would be here, negative 3, and then up 1. And I'll do 2 more. If I do negative 4, I plug that in, I get negative 4 plus 2 is negative 2, but absolute value would be positive 2. So negative 1, 2, 3, 4, up to positive 2, just like that. And I'll do one more. Negative 5, that would be positive 3. So 1, 2, 3, 4, 5, and 1, 2, 3, just like that. Alright, so there's the other side of my V. So you can see how the vertex has shifted over. And again, I'm going to take my highlighter, I have my pink one, and I'm going to highlight this function, and that's that guy there. There we go. Alright. So it seems almost counterintuitive. You added 2 inside the absolute value, but it shifted it to the left. The way I think of it is you have to kind of add 2 in order to get back to 0. Alright, because remember, absolute value has to do with the spaces it takes to get from that number back to 0. So it seems counterintuitive, but that's the way I think of it. That you have to add 2, that's the plus 2 here, add 2 to get back to 0, and that's why it had to shift down 2. Alright, so now we're going to take a look and see what happens if your h value is negative. Alright, so we're going to put a B, and we're going to draw our coordinate plane again. And we're going to be plotting both our parent function and our new function, which is going to be y equals the absolute value of x minus 3. Let's go ahead and plot this guy first. And I'll put these in here. So it's negative 2, positive 2, negative 1, positive 1, 0, 0, 1, 1, and 2, 2. So there's our V. Let's go ahead, use your highlighter, and highlight that guy. Okay. Alright, so for this guy, again, we're going to go ahead and make a table of values so that we know exactly where to plot our points. So I'm going to make this one really big because I'm going to show you kind of how our vertex is going to shift as we plot the points of this. So I'm going to draw X and Y again. And I'm actually going to start at 0 this time because I'm going to show you how the vertex is going to shift. So we're going to start at 0. If I plug in 0, that's 0 minus 3, that's negative 3, but it's absolute value, so it becomes positive 3. If I plug in 1, that's negative 2, but that becomes positive 2. 2, that becomes positive 1. 3, that becomes 0. 4, that becomes 1. And 5, that becomes 2. That might be enough. Yeah, let's start with those and see if we need any more. Alright, so let's start at 0, 3. So 0, need to add some more. 0, 3, 1, 2, 2, 1, 3, 0, 4, 1, and 5, 2. You know, let me do one more. If I plugged in 6, whoops, 6, let's see what would happen. That would become positive 3. Extend this. 6 and 3. There we go. And I'm going to draw my V going through these points. And I'm going to highlight in my pink highlighter. There we go. Whoops. There we go. Alright, so as you can see, when our H value is negative, it moves our vertex over to the right. Again, it seems counterintuitive, but the way I think of it is we have to move back 3 in order to get to 0. So it seems kind of against what you would think would happen, but you know, mathematically it does check out. We did plot all the points for that one and for the one that we did previously, and we plotted all the points and everything checks out. It seems to go against what we think what would happen, but you know, we did prove it mathematically. So this is what the different graphs of absolute value is going to look like. We looked at what how k would affect it, moves up or down, and h is going to move it left or to the right. So now what you're going to do is go over to IXL and you're going to practice the skills that we just did in the notes. Some of the ones you're going to see on IXL are going to be different than what we did here. They're going to add, you know, multiplying things to x or multiplying outside of the absolute value bars. Just do your best with it. We're not going to go too crazy deep into absolute value graphs. You'll probably get more into that as you go more into algebra, or even if you get into algebra 2. But again, just do your best with it.